in numerical terms is quite difficult or boring. And it would have been good enough if we could have visualized our data sets, right? If you could have created some plots. So if you have graphs or something or some visuals, it becomes easier for you to understand. In order to offer visualization, Python offers us a very powerful library, which is Matplotlib. There are several other libraries called Seaborn, Bokeh, and all have different kinds of features. The Matplotlib is the like first and very easy to use library, which offers you to create some interesting plots, and we'll see what kinds of plots we can create. So can everyone see this Matplotlib notebook? Is it visible? Can somebody confirm it to me? Yes or no?
Yes, Jyoti, continue.
So yeah, Matplotlib, it allows you to create graphs or visualize your data. So in order to visualize your data or use Matplotlib, you need to import it first, as we were doing for NumPy and Pandas, and you use this import matplotlib.pyplot function as PLT. So what it will allow you to use Matplotlib and plot graphs. So PLT again is the most widely used global alias. Here I'm using this percentage Matplotlib inline. So it's a magic function that allows you to create the plots well in your notebooks, in your collab notebooks itself. So first we'll import this. So PyPlot has all the plotting features. So we'll simply start with plotting a simple data. So what we have here is we have our data points for the x-axis, and we have data points for the y-axis. I'm creating an exponentiation graph. So I'm using np.exp function, which does exponentiation of each value for of the x. So now I have both the x data point and y. So SIP graph is basically a 2D, right? So we need two points like the x and the y, and using that we can plot our points. So if we to plot this, we simply use plt.plot. As I say, we are plotting the graph, right? So we use plot.plot method, and we specify the x uh, axis data points and the y axis. We can also tell the title of the graph. So you plotted the graph, but how does somebody else understand like what this graph is about, right? So for that, you can give title to your graph. So you have this dot title method, and here you can specify the title. You can provide labels to even your x-axis and y-axis. So for labeling the x-axis, you have dot x label, and for labeling the y-axis, you have dot y label. You can give your labels here, whatever you want, it should display. So if I run this, I get to plot here, and you see it's a beautiful plot, and it has this x label, y label, our data points, and they're all connected through lines and the title of the graph. Now I'm going to show you a simple figure to understand you the entire like anatomy of plotting a graph. What are the technical jargons or the terms which we come across. So in order to plot a graph, I'll just zoom in a bit. Um, yeah, so the graph is below components. So it has this title of the graph, and in case you have plotting multiple lines, it will have this legend. So what does this legend tells us is that what is this blue line about, or what is this red line about? We can this line which we get, it's known as line plot, and if we plot a particular point, it's known as scatter plot. We also call it as a marker. Then we have our x-axis label and y-axis label, which you already saw, and we have major text and minor text. Now what is major and minor text? So you see these grid lines, So these grid lines are what helps us to understand or um plot the values accurately. So for example, this point here, it's 2 on the x-axis and 2 on the y-axis. It just supports your graph. And wherever we see the numbers present is known as major tick label, and whenever you see a dash, it's known as minor tick label. Or we can even specify the values for minor ticks, and they are small, written in small, and the major ticks they are written in bold and with the larger font. So this is the basic anatomy of like figure or the plot which we make, and there's nothing other than this which lies outside. So we saw how can we plot one graph, but suppose if you want to plot more than one graph in the same figure. So for that we have a function called subplot. So what it does is it allows you to display multiple plots and that too within the same figure. Now suppose if you have your data and you want to plot the data and you want a sinusoidal and a cosine curve. So how can you do this? We simply use plt.subplot method, and what it does takes is it takes number of rows and number of columns and the plot number. So you specify that your plot should have one row and three columns. So your plots will and the plot number to be one. So the first plot will be on the first row and the first column. The second plot will be like if you specify the plot number as 2, it would be in the first row and the second column. And similar to you write in the dot subplot and then you do plt dot plot. Similarly, you again tell the first, like you tell the position of the plot and the plot number. And so if you run this, you see it plotted this subplot and it has three columns and one row, and the first figure is at 1, second assigned one at 2, and the cost one at 3. So we can even like adjust the size of the plot. So suppose if we want a bigger plot, so you see this has the size of 10,8. If we want even bigger, if we want say 15, width to be 15 and height to be 10, so that it's more clearly visible. So if I run this, you'll notice that it is a very big plot and it's more clearly visible to us, right? So using this dot figure and specifying the fixed size, which takes in the width and height of the plot, you can get a more clearer plot. You can even specify the dots per inch. There's a parameter dots per inch, so it gives you a more sharper or clear graph. So it's just another argument which you can give it to the fixed size figure method, similar to the way we are passing fixed size parameter. Now we can even save our graphs, and how do we save them is we use dot save figure function. So if you've plotted a graph and you want to save it, just given currently it's just blank because I've not plotted anything. I'm just giving the figure size and I'm saving this as the name saved figure.png. If I open this, you see I have this save figure.png image available with me. Since this plot is empty, you don't see anything here. It's just a blank canvas with width 8 and height 5. So that's it. Now, as you saw, we already saw we can provide title, access, and labels. Suppose if you want to plot multiple graphs, right? If you want to plot sine, cos, tan all in one picture. So you want that it should be labeled as well, right? So you can differentiate. So we see here we have plot two graphs and we have used different color, like it comes in different colors by default. And we've also provided us label. So here I have used like y1 and y2 as label, which doesn't make any sense, but just for explanation. But if you want to specify like whether it's you can write in like it's sine curve or so you can write as tan curve. So you can infer like what is this what are these blue lines about? What is this displaying? So this is how you can specify this as well. Let me just plot this. So you see here it got changed. It so the blue line says sine curve and this orange line says it's a tan curve. So this is how you can give the legend and how does this legend makes sense. Now, Matplotlib it offers this huge variety of colors. We have these are some commonly used colors codes which I've mentioned, and you can specify even the hex codes, and you can like create. Here I have this example where we've created multiple plots and I've specified the colors, and you see like how beautiful it looks. It has different colors for each plot, specified colors. You can like play along with. You can have different line styles. Like you can use solid line. It will look something like this. You can have dash lines. You can use markers, and you can use like different symbols. So here I've specified the list of line markers as well, and you can go through this, like it's quite a lot. You can go through this and whatever you find interesting, you can use it and plot these graphs. So like playing along with the code would make you understand things better and it would make more sense to you. I'll provide the link to this notebook as well. So here, see, I've plotted a graph and I've provided the color as well as the line style. So, for example, the first line style for the red color, it's solid. So you see this solid line here. For the second, it's dotted. So you'll see this dotted line for the blue one. So in case of dashed, you see these are dashed, and this is a colon kind of line style. So you can see basically the names, and it has different markers. So this is how you plot like different plots and figures. You can even add text or annotations to your graph. So, for example, you want to provide an annotation or some explanation here. So what you can do is you can use text method. You can provide the x position, you can provide the y position, you can provide your text here, and then you can specify the color of the text. If you plot this, it would return us this plot and it has this annotation with it. So this is how you can provide like some information which is necessary, and you can even annotate some points. So for example, if you want to specify like this is the minimum point, this is the maximum point, you have dot annotate method wherein you type your information, you specify the position of x and y, like which point you want to annotate, and you specify the position at which you want your text to be present. And then you can provide some styling, like here it's like round box, box should be rounded, and you want the arrow to be something of wedge shape, so you specify the shape, specify the color, and then you see this beautiful graph here. So this is how you can provide like you can provide more information within your graph, and we do use them quite often. So yeah, this is it. We've covered this all and this all. Yeah, even in subplots, like you can provide titles to individual plots and labels, and you just need to like repeat this. The views to follow, and here I've given the X label, Y label, and title, and it's just all same. You can give different titles, different labels without using for loop. You can specify custom titles for each plot and each labels. So yeah, this is it. Now we have different kinds of plots. Like what we were seeing till now were line plots. But there was a line drawn. If you want to specify certain points, right? So how can you do that? For that we have a scatter plot. So it doesn't joins all these points. It displays you the points as the specific point itself or the dot. Then here you see it's some like what do I say? It's like round or it's like a square shape. You can change the shape. If you want arrow shape, you can use the marker as the symbol. So the marker list is already present. I showed you it was just above. So it has some different shape. So it allows you to create like really interesting, beautiful, and well differentiated graph. Another kind of plot which we have is a bar plot. Now, what does a bar plot signifies? It basically allows you to establish relationship between two variables. So, for our taken example, we have fruits, fruit names, and some quantity for those fruits. You can make a bar plot and you can see like which fruit has the least quantity. So here you see it's pineapple, right? It has the lowest bar. Now, this is how you make a bar plot. So it will have bar for each property and it allows you to establish, understand like what is the quantity of apples, what is the quantity of orange, all these things. You can again use a different kind of chart, which is a pie chart. So, pie chart allows you to show the quantity in proportion. So here you see like these orange, apple, and one more lemon. They have the same proportion. Whereas pineapple has the smallest area. So similar to what if you have a piece of cake and you make pieces out of it to distribute among people. So that is what a pie chart is. You can visualize using plt.py function and yeah, we can even like we can play around. We have different parameters. If you will start executing it or you go through the documentation, you will see if I do shadows equals to true, we see a light shadow, darker shadow here. Here it's not present above. So, yeah, you can notice these differences. Now, the most commonly used plot which we perform like univariate analysis if we want to understand the data well, we use histograms for that. So what histogram does is it allows you to show the frequency distribution. So here you see that orange and pineapple have the highest frequency in this example. So suppose if you were having fruits, a list of fruits, and if you plot a histogram, so it will you'll see that the orange comes two number of times, pineapple comes two number of times, and apple and lemon comes just one number of times. So you see the plot, the bar goes up to 2 and here it goes up to 1. So this is what is fruits like histogram about. And yeah, this is again, suppose if we are plotting a histogram which has 100, it has 100 numbers and we want to see the distribution of data. So you see here it plotted this graph and we see all the values lie between the range -2 to +2 and the most common values lie between the range -1 and 1. So this is how you understand your data. Now we can even create 3D plots using Matplotlib, but I would want you to go and check this out through official documentary. So this was all about Matplotlib. And another like powerful library which we use quite a lot is Seaborn, and it has become quite famous. So I'll just walk you through it, skim through it very fast. So using Seaborn, we can create very nice visualization like different plots. So here I'll not cover the basics, rather I'll just explain you how do we plot these plots. The Seaborn is again used for visualizing or making graphs. So it's very extensive notebook. We'll share the link again, and these are the different kinds of plot which we'll create, and we'll be using them as well. So for creating these graphs, what I'm doing is I'm using a Titanic dataset. So it is a quite famous data set. So I'm importing all the required libraries in the very first step, and then I'll just load my dataset using SNS.load dataset. I've loaded Titanic dataset, and these are like fMRI tips and flights. These are like many datasets which I've uh, loaded, and then we'll go through the Titanic dataset. So we use the head method, and so it's just all same. We use head for this, and like just understanding what the flight data is about, what does the tips dataset contain. So Titanic has the details of all the passengers who were traveling through the Titanic ship, and tips is the data about the flowers, and or sorry, tips is the data that is about like what people visit restaurant, the details of the people, and how much tip do they offer. And flights is the data set about the passengers who travel through flights. So we have year, month, and passengers for it. We can go this in detail. Suppose here I'm creating a scatter plot and it's against the two variables. I'm plotting age and fare. So I'm using the dataset Titanic and I'm using the access cbond as I imported cbond as SNS. I'm using the alias SNS and I'm just using scatterplot function. Takes in your data frame or the data set first, and then your x-axis and then y-axis. These are some other parameters which we can use to make a graph even more understandable and uh, beautiful. So this is what we observe here. Now, what we observe here is if you see the people that are of younger age, they're offering they have the highest fares. So here you see the people aged like middle aged 30 to 40, they have the highest fares. And the old age people they travel like less and they have probably very low fares. Now if we use hue, what we can do, we can compare. So if we want to segregate what people are males and what people are females. So we see that the males they have spent quite a lot and they have paid the highest fare, and so it looks females were less and the males were more. So this would make more sense later. So this is how we info from the data. Now we can change the marker as well, as I told you, and we can increase the figure size similar to what we studied in like Matplotlib. So it's all same. And if I skim through this, we have line plots. So we have something called as relational plot. So it specifies you some interval or range, and we can plot a line graph or we can plot a scatter graph as well through it. So yeah, it specifies you some interval or range that the most data points lie around. So you see the number of passengers have quite increased a lot as the years pass by. So 1915 there were comparatively less number of passengers traveling through flights, and then there are more number of passengers traveling through flights and as the years pass on. This is the relational plot. Now we'll come through the yeah, these are other examples. Like you can go through this. It's a very extensive notebook with quite a detailed explanation. We can again like plot histograms. So for plotting histograms, we have two functions which are plot and histplot. So if you type in histplot and you plot in the age, you see that the people who were traveling in the ship Titanic were aged between 20 to 60. And you see, like everything is very intuitive. You just need to give in the plot name, you just need to give in the data frame or the column name, and it's just same for all. So yeah, here are like different kinds of plots which you can go and check in this notebook and explore. And it would be an assignment for you to go to all these notebooks. And one more assignment, which is you need to perform some basic EDA like I showed you on a data set, which I'll share. I'll share the assignment in chat. So this was all about the basic libraries which we use in ML, AI, and data science, which is NumPy, Pandas, Matplotlib. And other than this, I'll be covering TensorFlow, but I'll cover that on day 3. So this is it for today's session, and it has been quite a long. Tomorrow, I'll cover the introduction to ML and all the classical ML algorithms. So I would end this session here and I will share the link to all these notebooks so that you can go through them in detail. So, yeah, I'm stopping now. Is it fine? I guess the time is also.
Sure, sure, sure. Yes, thank you all